Hi, everybody. Thank you very much to come here after lunch, right? So my name is Inaki Villar. I'm from Spain, but actually I'm working and living in Thailand, in Bangkok. I'm working for Agoda. This is a company belongs to the Priceline Group, and it's like Booking.com, but for Asia, focusing Asia. It's here in the States and in Europe. It's not very well known, but in Asia it's very, very famous, Agoda. Okay, thank you very much to the organizers, to everybody, because it's my first time in Denver, and so far so good. Okay, my topic is about Espresso, and nowadays UI testing and functional testing, it's easier, right, with Espresso, with this library. But if we are talking about end-to-end testing or regression, I mean that if I want to execute all the tests in the suite before a pull request, but no user interface test, end-to-end test, maybe it's a little bit tricky, right? In Agoda, we have more than 800 tests, automated tests, and I mean, we are not testing the user interface. So from the beginning until the end, we are testing all the flow. It's a lot of time, but we are executing this automation test for every pull request. So imagine the important that is. But it's not the same like we are talking like, for example, with a simple UI test. Okay, this is the simple syntax of Espresso, right? If you know Espresso, that's why it's very famous, because this syntax is very simple. You have to think like, if you don't know, you have to think like a user. You have a user interface, and the first thing that you have to do is trying to find a view, right? That's why we have onView. Then we want to perform an action, and maybe later, maybe not, we want to check the result. So easy, and everybody can write this. Actually, in Agoda, we are trying to design one DCL of 2 layers, one for the QA, and the other for the developers trying to create the page objects, and we are trying to abstract more this syntax. But this talk is not about how to write Espresso tests. It's not about how works the syntax, where is a view matter, or things like that. This is more deeper. It's about how work Espresso, because if we want to provide an end-to-end framework to our company, to do more releases with more speed, we need to understand how works internally Espresso. And to understand, we have to analyze what's the structure of Espresso. So before, I say that onView is the basic operation, and if we see the Espresso class, that actually is the entry endpoint for Espresso, we are using a base plus whatever module. This is something that comes from the dependency injection Dagger in that case that is using Espresso. And I think that it's a very good practice to trying to read the graph of dependencies, because if the project is good, so I mean if the project is something that you don't have 100 dependencies in one simple component, it's easy to understand what dependencies and how is used this test. Okay, let's analyze the graph of Espresso. First of all, we have a main component. It's called the base layer component, and it's using 2 modules, the base layer module and the UI controller module. Each module is using different dependencies, right? We are providing different dependencies. Some of them are obvious, like the context, but we are going to stop to see some of them. Sorry. First of all, Activity Lifecycle Monitor. Activity Lifecycle Monitor allows us to check what's the status of the activity under test. It's unstable, but that is very coupled with the lifecycle of the activity, right? We have a state that is created, started, destroyed, and is used in the monitoring instrumentation class. This monitoring instrumentation, that's something that is known from the Espresso. It comes from the JUnit, from the runner, from the new runner. And if you are thinking about the instrumentation part, so the monitoring instrumentation, if we see the stack, it's here. So imagine that before, well, at the top, we have instrumentation, then we have exposed instrumentation API, and then the monitoring instrumentation, and at the end, Android JUnit runner. Android JUnit runner is the runner that we are using in our test, right? And is the replacement of the old instrumentation test runner. So monitoring instrumentation is using different advanced techniques to try to ensure that the application under test, it has a good state. For example, the method application on create happens before its instrumentation start. That's something very important because you want to ensure that the state of the application is something that is safe. Okay, and how works this relation between the monitoring instrumentation and the activity lifecycle monitor? Well, we have a hook here in the monitoring instrumentation, and every time that something happens in one activity, we are sending to the lifecycle monitor the state for the activity, in that case, destroy. Okay, another dependency is activity root lister that provides access to the main, well, to the root of the views of the application. The doc says that 95% is not required because when we want to do a test, the main view we can get by get window, get decor view. But if you have dialogues, if you have menus, or you have other views like a snack bar, here maybe you can have a problem. And if you are working with Espresso, you know that sometimes when we want to test snack bar, we are using the not in root. And that's the reason, because it's happening. Activity root lister works with a window manager global. It's trying to get all the views in all the params, analyzing the hierarchy of views. And we can access, when we want to test, when we want to do a view matcher, that's how it's going to work. A syntax pool monitor, is very interesting class because it's trying to monitor what's the status of the queue of async task. This class is using by two components because we have two different syntax. We have the compat and the old one, and the new one included in the compat syntax. And the main functionality is to check if the queue is idle, right? How we are going to do? Well, we have a monitor. If you are in Java since years ago, you can see that this class is using some concepts from the concurrency framework of Java. Very interesting. But the good thing here, if we can see, so to check if the queue is idle, so it's checking the pool, right? This pool is a ThreadPoolExecutor, and that's something that is very interesting because that means that this class is nothing to do with the syntax. We are trying to inject one ThreadPoolExecutor. In that case, this ThreadPoolExecutor is a syntax queue that is populated by these classes. So that means that we can use the same approach to other ThreadPoolExecutors. Imagine that I want to follow the same example to my executor service that they have in my entire application. We can use the same approach. In fact, years ago in the code of Android, they were using, with this approach, all the synchronization with the idle resources. So the idea is that I have one queue that I want to check if something is happening, because if nothing is happening, my queue is idle, and I can do an interaction. We have a ThreadPool extractor that by refactor is trying to get all the syntax, or in that case, modern syntax, pending in the queue. We are going to see later more about this class. The event injector is responsible to select the strategy to inject the events in the user interface. It's using for the API above 16 and 16 input manager. For previous, it's using global manager. And at the end, so the thing that we are trying to do is inject or invoke the injection of one motion event. But again, so Android is working with the input manager. So we are trying to get the input manager instance by reflection to the staff. So, talking about the UI controller module, we have this class, this dependency that's the UI controller, and it's like the key of Espresso. Actually, provide base level UI operations and allows the user to build interactions like scroll or click. So we can understand or we can guess that these different actions are injected by our test. Something that can be familiar now is like the dependencies that we are using. We are using an event injector that we saw before, and a syntax monitor, and an idle resource registry. As you know, the idle resource is one technique provided by Espresso to do the operations in background, to wait till the operation in background is done. And this class is trying to check that all the idle resource registered in the application are idle. This class is the key of Espresso. Later, we're going to see more about that. We have more components. We have the view interaction component, and as well, the same as Dagger, we are trying to add a new model, view interaction model. And here, in that case, we are providing dependencies more related with the view interactions of the view. Funny thing is like viewfinder. This is very familiar if you are working with Espresso, because it's the one that is returning these two exceptions that maybe you have seen more than 100 times if you're working with Espresso. And returning to the initial explanation about the internals, we saw that when we are calling onView, before we were saying, oh, we are doing some operations with a view component or with a component and then with a model. And now we can understand better what's happening behind, right? So we have a view interaction model, that's the model provided in the component, and we have the base layer component happening. And this is returning the view interaction. So every time that we are doing onView, this is the thing happening behind the scenes. We need a view matcher. The view matcher is like the way that we are trying to say Espresso how to match a view. You have a user interface, and you have to know how to say, hey, I want the first view with this ID. Okay, this is more about how works the matchers in Espresso that we are not going to see, but the idea is, given a view matcher, we are returning a view interaction. This view interaction is the one that allows, at the end, to apply the final part of our simple syntax. Given an onView, we can do perform an action or assert a result. Check the result. Okay, now we are going to see the second part. It's about the synchronization, and one of the top features of why Espresso is famous, because it's the synchronization, right? We have here one thing that we have the instrumentation thread when it's running all the tests, and then we have the main thread. If you want to do something with the main thread, or with a view, sorry, you need to do in the main thread, right? How it's possible that from the instrumentation thread, we can do safely something on the main thread? Well, thanks to Espresso. So in the moment that you are doing a onView, perform or check an action, you don't have to be worried about anything. Espresso is doing for you, and that's why it's famous, because the synchronization and because the easy syntax. And let's see deeper how it works. Imagine that in my activity test, I'm performing an action. I want to do a click. If we go through the different steps, we can see that first of all, we are going to the view actions to perform a general click action. You can understand that, for example, we have a long click, we have a click, we have different interactions, and it's handled by the view actions. Later, we're going to the motion events, because a click is based into different events. We have to send down the finger in that case, imagine that and then up, right? Because if you are spending more than 1 second, 2 seconds, it's a long click, right? So this class is trying to simulate the action to a single click. And finally, we are going to motion events to use, again, UI controller, this class, to do the inject motion event. Okay, again, we have seen UI controller. And we have to ask this question: how is possible? So in the moment that I want to perform this action, that everything is fine inside the main thread. Well, we can see in a graph how it works internally. We want to do, in that case, I think that I want to type something in one of the text, right? So I want to do this type A. Remember that we are using the event injection. And we have one method in the UI controller, in that case UI controller implementation, that is looping the main thread until it's idle. That's the name, right? But the idea is, you know that before we say that we have the main thread, we have the async pool monitor, and we have the idling resource registry. So Espresso is trying to loop all these two queues from the syntax for the idling resource and the main thread until everything is idle to perform my operation. So, and that's why in the moment that I'm performing this action, everything is idle. And that's the UI control implementation, how it works. Once everything is idle, I can call my event executor, and finally, when there is nothing again in the main thread, I can do my operation in the main thread. And this is very important because, well, and it's free. It's given free by Espresso. But it's very important to understand, because if we want to provide something to our company, to our workers, we want to help QA, we have to understand that nothing happens in the user interface until the main thread is idle to do my action. If we see the code, well, the code is reduced. We can see that, of course, we have the check to check if the task or the queues for the syntax, for the completed syntax, or for the idle resource are idle. If they are not idle, we can loop until the conditions included in the queues are idle in that case. If you can use now under the Studio 3, or well, in the previous version as well, you can do a trace of with the CPU profiler, and you can take, for example, this screenshot to check what's happening. So we have this key event action, so it's opening a new thread, and look what happened here. So here we have a call of the UI controller implementation. So in the moment that I want to perform this action, we start the process. Finally, when it's done, I can inject the motion event. And who is doing the action at the end? The input manager. And the input manager belongs to the Android framework. It's not about Espresso. It's how Android internally perform the actions. So maybe it's not easy at the beginning, right? But so the idea has to be very clear. So work until everything is idle. And this is by default the behavior of Espresso. And that's quite cool, right? But in the real apps, we have different situations, right? So maybe I have operations of network, of databases, and in that case, I can use idling resources. Idling resources try to fill this problem that we have. In fact, you remember that we have one class. Oh, here it's okay. That is idling resource registry. So if I want to do operation of network, I can register an idling resource, and it's going to work. That's okay. But imagine that you have operations on network, databases, and more heavy operations in the background. So we want to provide a solution that would be a standard for everything. I don't want to create 20 idle resources in my application. So that's why we are going to give two different tricks depending of the threading model that you are using in your application. So a month ago, there was one report from JRebel asking to the Java developers, no Android developers, what is the most used threading framework in the Java world, right? And with difference, the most used is the Executor service, right? So it's quite popular with the ThreadPoolExecutor. Nowadays, with RxJava, it's not so popular in Android, but well, if you have years ago, you remember that we are using Executor service all the time to apply these things. We can use this cool trick to try to handle this situation if your app is working with ThreadPoolExecutors. So Java, you know Java, the library, is having one class. Is called, well, for simplicity, I try to short the name, but it's wrapping Executor service. It's an abstract class that allows the subclasses to grab tasks, and before we are submitting the task in the Executor service, we are trying to delegate in the underlying executor. That's quite simple, the idea, but imagine that in my Executor service, I want to submit something. The thing that I'm going to do is wrap the call. So that means that I can do something before and I can do something after. Here you can see better. So the moment that in your executor you want to execute a runnable or callable, you are submitting, but you are wrapping the task, okay? So if you are not using this library in your project, or it's hard, or you don't, or it's not accessible, the dependency, you can use the most advanced technique in software development, and you can copy the class, right, in your project. And that's the thing that we have done here. So we have defined this Java wrapping executor service, and it has two properties. One, the executor service, the delegate, and the idle resource. Again, this executor service we can inject by Dagger, whatever, but represents the ThreadPoolExecutor of my application. In testing, easily, you can use this injection. And counting idle resource is idle resource, but with an internal counter. It's quite popular as well. Again, so remember that before, so this class, it's implementing, you have to implement, if you extend from wrapping executor service, you have to implement this abstract method, wrap the task. And that's the thing that we are doing here. We are wrapping the task, and at the same time, we are creating a new inner class. But here is the key of everything. Like, I'm wrapping the task. I can increment my internal counting idle resource. I can execute or the executor service, the delegation, and finally, I can decrement. So that means that always my ThreadPoolExecutor is always synchronized with Espresso, because this is an idle resource that this idle resource is going to be registered in the idle resource registry, right? And this is taking into account for the UI controller implementation. So I'm wrapping the call of every executing service. Increment, execute the task, and decrement, and always I'll be synchronized. But to be fair, right, so we are using nowadays, a lot of people RxJava, right? So we are not using executor service. And with RxJava, the idea is very similar. I can create the same class. You have the RxJava schedulers hook that allows you to inject different schedulers to your app, more things, but it's one of the features. So I can do with the same idea, I can create my counting idle resource, same technique, and I want to create a custom scheduler. This custom scheduler is going to use, is going to create a worker, and this custom worker is where is going to happen the magic here. So you can guess, right? My subscription, my action, when I try to call, I increment the idling, the counting idle resource, execute the action, and at the end, I decrement the internal counter. And this works. So actually in Agoda, we are using this the same, and works very well. So we don't have to worry about anything of the RxJava with Espresso. And well, if you are at the moment when you are instantiating the invocation of the instrumentation, you have to inject the scheduler hook. But if 2 days ago, there is a new library called RxIdler from Square that is doing the same, but better, of course. And you don't have to do anything about wrapping the scheduler. So use this library if you want, because it's from 2 days ago. and works with Rx1, Rx2, and it's doing the same. But it's good to understand the idea, how it works internally, because the idea is the same. Wrapping the action before and after, and I have the synchronization. Okay. Once we know that it's key, honestly. So if you want to do something not only to do some UI tests, if you want to do something more ambitious with Espresso in your company, you have to design very well the synchronization stuff with RxJava or with Executor service, whatever, because will give you and to your team to QA, so to don't think in these things, right? And focus in writing tests. So once we know that, we want to know how to organize the things, right? Because again, the idea at the end is write tests, right? But if I want to write tests, I have to forget, well, I don't have to be aware about cleaning stuff on the app. I don't want to know how to take a screenshot when something is failing, and this stuff. And that's where rules is helping us. So first of all, if you work with Espresso, you know that we have this activity test rule. That's the entry point and reduce the boilerplate that we have to add in our test. So once we are declaring activity test rule with our activity, this is the entry point from our test, and we don't have to take care about anything. I can do that, and I can write my test. Perfect. So it's implementing some, we can implement some methods, and if we want to do something before the activity is launched, after the activity is launched, or after the activity is finished, we can implement by ourselves something like that. So it's allowing to give us some functionality as well. We have the intent test rule that is extending from activity test rule, and the only difference is like we are trying to create some intents, or we are trying to create some wrappers in the intents after and before the activity is triggered. Yeah, after the activity is launched and intent. But what is the test rule? Test rule is something from Espresso? No, test rule, it belongs to the JUnit framework, and it's nothing more than an alteration and how one test or one method of the one test is run and reported. So simple. So here we have one test rule from Espresso, the UI test rule, and the things like we are doing here, that case, as you can see by the name, is checking if we are in the UI thread. We are returning a statement, right? And this statement, so again, the test rule, so when you implement a test rule, you have to implement the apply, right? And the apply is returning a statement. This statement is the statement belongs to the activity test rule, in fact, right? And look what's happening. And the moment that we are evaluating, that's the interface for a statement, here we are launching the activity. And that means that when we are using activity test rule, the first thing that we are doing is launching the activity. And we execute the test, finally, finish the activity, works. And you don't have to deal with anything. Activity test rule, main activity, onView, whatever. That works. You don't have to do anything. So, and that's the idea of the test rules. But that means that you can create your own rules, right? So in that case, we are trying to create a simple test rule that before the base evaluate is the execution of the test. Before the test, I want to get some data from the phone, for example, or from the emulator. And at the end, I want to end this tracking memory. And if I want to use the test rule only in my test, I have to specify with annotation rule the instance of my new rule. Okay, more things. We have the test watcher inside the test unit, and that's something very cool because it's like well, you have like hooks in the life cycle of one test. So that means that, well, imagine that that's the simple, well, that's the test rule. Here is the evaluation of the test. And we have these listeners, or we have these hooks to inform what's happening. For example, or the life cycle. I'm starting, it succeed, there is a, well, skip the test. there is one problem, and finally it's done, the test. So I can do this thing with this test watcher. I can create a test rule called failed test. I can instantiate the UI automation, and then when it's failing, because I override in the test watcher, I want to take a screenshot. That means that every time that one test is failing, I'm going to take a screenshot in the life cycle of the test, with no tricks, with the life cycle, with the test rule, with the test rules implementations, but at the same time, I can override other parts of the life cycle. So next, the rule chain. The rule chain as well for the JUnit is a functionality to trying to add more than one test rule at the same time, right? This is the documentation from the JUnit, and imagine that I have the outer rule with some message, and two log rules around this outer rule. How will be the result? So if we imagine that this log rule is printing something on the screen, that means that I'm starting the outer, the middle, the inner, finishing the inner, middle, and outer. So it's like I'm combining different test rules in one rule chain. And let's recap a little bit. So we have this activities rule, and I can do that. So I can create my rule chain with the other rule that's the failed test. That means that when something happens, I want to take a screenshot, and around the activity rule. But I can go further, and I can create my rule chain that the outer is taking the screenshot if something goes wrong. Then I want to trust to perform the operations to measure the performance or whatever around the activity. So that means with one rule, one chain rule, I can do a lot of operations, and that's very good because remove a lot of boilerplate that you have to do in every interaction with the test rules. Okay, again, so I think that it's important as well how to design the strategy with the rules, because at the end, I want that the people, for example, a good practice to understand the project is write tests at the beginning, and they don't have to deal with which activity I want to take a screenshot. So try to define rule chains in your test, and will be helpful. Okay, and what's next? In Espresso, yeah, of course. So last Google I/O, there was a presentation, and Google released the Android test orchestrator, and we are very excited with this announcement. And that's something cool because in Google, they are working both. They said in the conference, when you're trying to run in our case, when we want to run a suite of 4 tests, for example, first of all, I'm invoking the instrumentation, and then I'm executing the test. In Google, for every method, for every test, they are creating his own invocation. So imagine that you are starting the application every time that you are going to do the test. And that's something that for Google works very well. It's trying to avoid, for example, the share state. And they say that it's not the share state in the app. It's the share state in the memory, in the disk space, or something more about the framework. And that's something that I think that could be very good for the developers. How it works? Okay, imagine that you have the Android JUnit runner, so that's the process. And we are using 2 APKs, the normal APK and the test APK, right? With Orchestrator, we are trying to, we are going to install a third APK that is the Orchestrator. This is a background service, and it's going to instrument the app. So you are not going to use the instrumentation through the JUnit runner. You're going to instrument through the Orchestrator. And the Orchestrator is going to do the test one by one in a single instance of the Android JUnit runner. So sounds very interesting, and I can't wait to see when it's released to see because maybe it's can bring another improvements, right? So for example, if you are doing sharding means that you are executing tests in different devices, and you have one exception in one test. That's something that It doesn't have to happen, right? But you have one exception. The entire sharding for this process, for this phone, is stopped. Imagine that if you have 800 automation tests, 200 per device in four devices, and something stopped in the second test, maybe it's a waste of time. And with Orchestrator, this is not going to happen because every test is a single instance of the Android unit runner. Okay, more news. Multiprocess Espresso. So the idea is like you have your activity, and your activity, you have your instance of Android unit runner and the Espresso. If your interaction is clicking a button and opening a new activity, you are creating a new instance of a new process of the unit runner Espresso. And the communication is not guaranteed in that case. So the same thing that Espresso said that the synchronization works well with the UI control implementations, they don't say anything about this kind of communication, right? And that's why Multiprocess Espresso is trying to, well, to solve this problem. And now you can communicate between the two different processes with the Multiprocess Espresso. The important part here is like in your test, you don't have to update anything. And by default, they're going to, behind the scenes, update all this communication. OK, and last, this is not from Espresso, but that's something that is quite interesting. In the new version of the plugin of Gradle with Android Studio 3, you can see you have a new configuration called Android Test Utils that allows you to install an APK before the instrumentation runs. So if you know Test Butler, that's a very known app to do the test, trying to disable the animations. And you can, with this configuration, you can install this app before everything happens, and you don't have to do any trick with ADB or whatever. And well, you have all the information in, well, except the last part of the Android test utils. You have all the information here in the video of Google I/O. There is no the link, but it's TDD on Android. But although the title, it works with, talks a lot about Espresso, Orchestrator, and Multiprocess Android. OK, in the last slide, usually I used to put names, projects, but well, as we saw yesterday, so well, we are a lot of developers nowadays, and that's impossible, right? And I think that the only name that I can put here is the Android community, because it's like the things that one guy like me that travel around the world to come here to give a talk about Espresso. So thanks to the community, and thank you very much to attend this talk. Thank you, guys. If you have some questions, we have 5 minutes.